that the column must have the categorical value. Okay, and this quality has not the categorical value. Okay, so if there is no categorical value in the data set, we cannot apply the classification algorithm. Okay, so I take another file so that I can apply the classification algorithm, because this data is not suitable for the classification. Okay, for example, I take this mobile price. Okay, so I share you this file. I hope I already share you yesterday also. Please just change here. Load this mobile price.csv, because if we don't have any column that are categorical, we cannot apply classification algorithm. Okay. Now we have to test the column. In Naybase, there is a means visualization of results is not possible. So we can use directly the testing values. So I use here test and score, and I have to connect okay, 1 second. Here also we require a select column, because in the supervised learning, both for the training data and testing data, one target column is required. Okay. So here also I am taking the same target column. Okay. And now I am using this test and score. Okay. And now you can see the accuracy, precision, F1 score, all that you can see here. I am taking Wi-Fi as a target column. Yes, it is compulsory that for both training and testing data, we have the same target column, because we are testing the data set for the same target variable, not for the other target variable. Can also the confusion matrix to check that how many false positive and false negative results are there. Training and testing is a two part of the data set. In the data set, if you see here, we divide this data set into a two part. One is this, one is this. This data set I connected with the algorithm, and this data is called training data. That is used for constructing the model. And the data set that we are used only for the testing is called the testing data. Understand? Everyone completed this? This is just for the representation. Okay? In many research paper, you can find that before declaring the result, mostly people are showing the confusion matrix. Because all these results, the AUC, the precision, the recall, all these are derived from this confusion matrix also, only. In confusion matrix, there are 4 values. You can find this is a 2 by 2 matrix. This is a false positive, false negative, true positive, true negative, false positive, false negative. Yes, you are right that the test score widget is taking the testing data and the algorithm as an input and produce your result. Means test the model. If you don't want to use the confusion matrix, not a problem. But in the research paper, mostly people are using the confusion matrix. Yes, Python script widget is available, but what we can get, I don't know. I have to also test that what result we get. Actually, this gives you a result of this only, confusion matrix. You can see here. And this same values, this same algorithm is not able to run in the directly in the Python or any Python notebook. Yes, there is a lot of the use of this matrix. I already tell you that the values that you are getting, like accuracy, F1, precision, recall, all have the formula. And the formula is based on 4 values. And all these 4 values are available in this matrix only. Okay? Actually, if you test, for example, I give you the formulas, means what are the different formulas. Okay? Actually, every time when training and testing data is derived and you are clicking on the test and score, every time the whole script, the whole flow is run. And every time in the training and testing, you get a different data. And that's why the test score is changed. Okay. And if you want to fix the test score, in that case, you have to fix the training and testing data. If you don't fix, this value always changed. Okay, let's I give you the formula. You can see this is a formula of the accuracy. Means what is the accuracy? Accuracy equal to true positive plus true negative divided by true positive, true negative, false positive, false negative. And I already explained you that all these four values, true positive, true negative, false positive, false negative, is available only in the confusion matrix. So for calculating all this accuracy, precision, recall, you can see this precision and recall formula also. And for calculating all these values, this confusion matrix is used. Understand? Okay. Any doubt in that? Okay. So the next algorithm we are going to discuss is a random forest. So random forest is basically a extended version of the decision tree algorithm. Okay, if you want, then it might be possible. There is a, because ROC is nothing. ROC is just a curve. ROC is the full form of ROC is a receiver operating characteristics curve. This is a curve that is shown to uh, visualize the model result, and if the ROC value is less than 0.5, it means that the area of the curve under the curve is not good. So in the maximum cases, people are doing that for giving the good result, the AUC value must be greater than 0.5. Okay. And if you want to give only the numerical values as a result, there is no use of the ROC. But if you want to give the numerical as well as the visualization, you can use this ROC. Actually, in the PPT, you get all these formulas and all that, how the algorithm is working. But in these 3 days, both orange and this is not possible. That how the algorithm is working. Okay, so I directly explain you that how to use only these algorithms. Okay. So if there is a confusion matrix example is here, I will explain you. Okay. So for example, this is a, yes, I surely send you the PPT. Okay, not a problem. Okay. So for example, in the PPT, you can see that this is a one confusion matrix. Okay. Okay. In this confusion matrix, you can find this is a 2 by 2 matrix. Okay. And on the basis of that, and this 6954, what is this? This is a true positive one. What is this 46? That is a false negative one. What is this 412? That is a false positive. What is 2588? That is a true negative. Okay, we have to just remember this position. And after that, if you want to calculate this precision recalls and all that. So what is precision? Precision, what is precision formula? The formula of precision is a true positive divided by true positive plus false positive. Okay, this is the formula. So what is the value of true positive? The value of true positive is a 90. And what is the value of the true positive plus false positive? This is true positive, this is false positive. Then total is a 230. So what is precision? Precision is a 39.13%. Understand? So means on the basis of this confusion matrix values, we can calculate manually how the precision, what precisions we are getting is correct or not. Understand? So that's why this confusion matrix is important. And in every research paper, if you find where any person, any researcher is using classification, in all the papers you find first the confusion matrix after the results of the model. Understand? Any more doubts? I will share you this PPT also. Okay. So hope everyone understand the need of this classification, and I can also explain you the ROC. So in the ROC, you can see this type of curve, and this curve having the two dimension in x-axis, it gives you a false positive rate that is also derived from the confusion matrix. And in the y-axis, this is a true positive rate. And this line in the middle line, this is a straight line in the middle, is dividing the curve into two parts, means half portion, half portion. And if you find this curve above the line, it means the model gives you a good result. But if you find below the line, the model are not considered as very good. So in all the, mostly all the researchers try to find this area under the curve greater than 0.5 so that the curve exists here, not here. Okay? Understand? If any doubt, you can ask. Okay? The next algorithm I am going to use is a random forest. And this random forest is also considered as the extended version of the decision tree algorithm. In decision tree, you can make only one tree, but in random forest, you can make multiple trees. And from the multiple tree, you aggregate the result and get the result of the model. So the chances of good result is more in random forest as compared to the decision tree algorithm. So if the data set that you are using not gives you a good result in the decision tree, you can try random forest algorithm for improving the result. Okay. So in this question only, I remove this tree from here. And include the random forest. In that case, the tree viewer is not used. Means the same procedure you can follow, but you can change the algorithm. And you can find the changes in the results. Or you can make a two different workflow and check what differences you can get. And in the random forest, when you double click, it tells you that how many trees you want to prepare. For example, by default, it is taking the 10 trees. Okay. So if you want to increase, you can also increase the number of trees. For example, in place of 10, I want to make the 20 trees. Okay. You can see the changes in the result. And you can see the changes in this result also. The accuracy of the model is also increased when the number of trees are increased. Okay. Hope everyone is understanding. Any doubt in this? Okay, please perform this. You can also take another data set. For example, I am changing the data set. Now I am changing the data set to the breast cancer data set. Okay, I take this data set. Okay. Now I have to check this breast cancer data set is available or not. So you can see that this data set size is very big. But the number of columns are more as compared to the number of rows. Okay. So in all the cases, if you are changing the data set, you must have to change the select columns. Okay. And it is compulsory for all the algorithms that you don't have any categorical column in the independent data set. So I am taking this data set, adult census data set. This adult census income data set. You can take any data set where at least one categorical variable are there. In this, you can find there is a 15 categorical, but we require only one for classification, at least one. Here also, I have to change in the select column. That we have to ignore all the categorical column because we cannot take any categorical column as a independent variable. So these all are independent and I take income as a dependent. Or if you want to classify on the basis of the education, you can take education also. But in that case, you have to remove this income. Okay. Now you are finding that you are getting various errors because in both there are different target columns. So what error I am getting? That the least populated class in Y has only one member, which is too few. Because for classification, you required at least two variables. For example, yes, no, 0, 1. So this is a problem. So for that, it is telling that you cannot choose the education as a target variable. So for example, I am trying with the marital status also. Okay. Actually, the size of the data is very big, 48.8 thousand rows are there. Okay, so it is giving the error that the sample size must be as enough as possible to classify the model. Okay, and now you are getting this value. Okay, so you can take any data set, build a model, but you have to choose that which column you are taking as a dependent column, and all your objective of research is based on that dependent column only. Okay, this is a ROC curve, you can see that. And this is a 0.5